concentrate rather on the output case. So there's quite a few things we need to do. First thing, these gaps here. What are they doing? Well, they're here to provide space for an adjuster so that we can adjust the tension in the bearings. Now, in the gearbox artifact study this semester, you'll see that gearbox has these adjusters in place. And apologies to the people that were let down by the demonstrator last week. I don't know what went wrong with them. I think there's two demonstrators. They both thought the other one was doing that particular lab, so neither of them turned up. Anyway, so we've got to put an adjuster in there. The adjuster is the simplest thing you can imagine. It's just basically a dish that pushes on the outer raceway of the bearing. So, we'll create one of those for the input shaft, I think, to start with. And let's have a look. My starting point would be, what diameter is this here? And the simple answer is, it's a 26 radius, so it's a 52 diameter. And then for the, well, let me start drawing the thing up. So we'll do new part. Okay, and we'll do a sketch, I suppose. Sketch, reference plane. Start off with a centre line over here. And then I'm going to draw a sort of an upside down L shape. Like so. And we'll put on a diameter for here. That's much bigger than one. I'll make it something small for the moment. And this has to be the outside diameter of the bearing, so that was 52. I'm taking a guess at the thickness at the moment of this as being 8. And let's just drag that back in there. Right, so we need some dimensions for the depth of this thing and the diameter of this thing. So we'll put on a depth dimension there. And where we're going to get this, I'm going to put in 3 for the moment, and then we can adjust it. Where we're going to get this is from the bearing table. So we'll start off by me checking which bearing I'm using. So this is for the input shaft. So input, and it's to go up against the right hand bearing, which for me is a 32205B. So if I now look at my tables for bearings, and 33205B, 32205B, sorry. 32205B, so it's that one, which more or less lines up with that one there. And I have to look for my DA and CA dimensions. So the DA is between 41 and 46, and the CA is 3. So I already guessed that 3 is being the depth. So we need now a value between 41 and 46. So something like 43 will do quite nicely. So go to the solid model, set that as 43. Was fine, so that's okay, so that's got the sketch done. And then we'll create a revolve feature. I'm not worried about embedding the sketch into this revolve feature because it is the only thing that's going to be using it. So that's got that done. And just a couple of little niceties perhaps. We'll put in a little fillet in this corner here. Just a 1mm fillet, I'll do these two outer corners and this one going round in there. Okay, so that's all it is. It's just a little dish and it will push up against the bearing. So we'll save that. I'll save. And put the right folder there, and we'll call that adjuster input. Okay, now I also need one for the mid shaft. Now you can do fancy things like families of parts and so forth, but for this I'm just going to do something very simple. I'm just going to do save as, and I'll just save it with a different name, and we call this one adjuster mid, and then I'll change the dimensions to suit. So I happen to remember that my mid-shaft bearing is 62 diameter instead of 52, so that's the first thing we have to adjust. So sketch there. Oops. Okay, so that will become 62. Spreadsheet at the moment, mid is 32206, so again it's the right hand bearing. Look at the table, 32206, 2206, this one just this side of the 3.5 there, so DA will be between 52 and 56, well I think that's 54, and again it's 3D. And it's starting to look a little bit shallow, the dish now, you know, if you push in the middle it might buckle. Now it's a bigger diameter, so I'm just going to increase that very slightly. That's probably enough, actually 9. 9 or 10. Save that, and the rest of it's done. So there's my dish for that one, so we'll just save that. I'm going to sit down here, it's easier for me to see the screen. Okay, so shut those, and we're going to put them in these spaces here and here. Before we do that, at the moment, the axial alignment of the shafts is determined by a space that we put in of, I think it was 10 and 12, I'm not sure, down here on the mate relationship. So let's expand that up and have a look. See, we have a distance there, and we have a distance there. Well, when we put in the adjusters, we won't want all of that. So we'll delete those. So just select them and hit delete. So there's nothing holding those in place axially now. Okay? So we're going to have to add in a different relationship. And the reason I'm deleting that is because really the position of this isn't perfectly defined. The reason why we have adjusters here is because all of these components have tolerances, and we need some way of taking up the tolerances, so the distance from here to here won't always be exactly 10 or exactly 12. So we need to push this shaft up against something which isn't going to move, and the thing that's not going to move is this surface on the input case. Okay, that's machinable size and the bearing butts up against it. So it makes sense that we actually make our alignment relationship with this surface rather than this one. So what we'll do, we'll go to assembly and we'll do mate. And as soon as you select mate, and it won't let you do this until you select the mating relationship. Once you do that, you can grab this shaft and you can move it. Okay? Now it's no longer constrained. Unfortunately, it sort of rotates as well, and that means the section through it rotates. But the section is a virtual thing. It's only there because it remembers that that's where we sectioned it. If we actually delete the section and put it back in straight through the middle as the way it's supposed to. So, now we've moved it out of the way, we can add in relationships very easily. So, if we select this face here, and we select this face here, you see it immediately wants to line up on that. Sorry, it's moved off the side a little bit here. Okay, so it's now lined up against there. So happy enough with that. So, okay. Let's do this bid shaft now. So we move that one out of the way as well. And we'll do a mate with the end of that. And the end of that. And again, that's got that done. Okay? Now if you're worried about these sections being twisted, all we do is we just turn that off and turn it back on again, and you see that's got that fixed. Okay? So, now our shaft is not aligned to this case, it's aligned to this case. So we can put in our bearing adjusters. So, insert, browse. Okay, so adjuster input. And quite often when you plonk it down, if you've got a section view in place, it doesn't show it. You just turn it off and back on again. And there you go. Now we've got that adjuster there. So we want this cupped face facing the bearing. So mate that face there and that face there. And it's hidden itself down here between the various parts, but you can just make it out. So we'll accept that, and then we'll take this diameter here and align with that diameter there, and that's got that done. We can actually do lock if we want as well, stop it rotate, oh, maybe not. Screw that up nicely. Right, stick in a relationship there. There you go, do that. I think I'd have to do lock now, I'm not sure, whatever. So that's got that one in there, and the dish side is facing the bearing. So let's do insert the other one. Browse. Adjust the mid. Okay, so we'll just plonk it down here, turn the section on and off. That's unfortunate. It must be forward of my cutting plane. So what we'll have to do mate, and then I can drag it off to one side. I can turn this, or cancel that. Turn the section back on so I can see what I'm doing. Select this end face here, select the end of the bearing there. Sorry about this, I'm not looking at what I'm doing. That's got that, and then do the outside diameter there and there. That's got that in there like so. And we can turn the section on and off and show those both in section. Alright, and you can colour them up with some appropriate colour at some point. Now one thing that's important is that these have a gap behind them. If they don't have a gap behind them, then they can't adjust. So if you put in your adjuster and it doesn't have a gap, then you have to make the recess a bit deeper. Okay? So you need typically 2 millimetres. And the underside of the dish against the bearing is dished so that the inner raceway can't possibly rub against that. Okay, let's have a look, see what depth I've got on these things. Sorry, evaluate. 2 millimetres on that one. And I've got 3 millimetres on that one, so I can make that recess 3 millimetres, 1 millimetre less deep, if you like. So I think we'll do that. We'll open up the case and do that, sorry. There's a sort of a whittering, whispering going on here. I'd prefer it if you stopped. So let's do this one here. Right, so it's going to make it 1 millimetre less. Let's got that done. Then I'm going to section this up and see what I'm doing. And these bosses don't need to be as long as they are, but until I've got to this stage, you can't really adjust their length. So let's have a look. We've got here, evaluate this one here, from here down to here, has an axial dimension of 23. Now the end thickness on this wants to be about the same as the case. So if we say that was 7, that means that the boss is 16 millimetres too long. Okay, so we'll adjust that. So at the moment it's 50, so that's going to be 34. Okay, let's do this next one. And that's 20.25, so it's 13.25 too long, which is slightly off dimension. 13.25, so let's adjust that one. Well, it's 50.25, so that's why the 0.25 was there. So that's going to be 37, is that right? There you go, that looks to be about right. Okay, what else can we do while we're here? It's about time I did something about the second bearing in the case. Now the way you go about this depends very much on whether your bearings are the same size or not. For me they are, so it makes life very simple. So if I open up my spreadsheet and look at the output shaft, I discover that my 2 bearings are the same size. If they're not, you know that DA and CA thing, you'll have to actually do a partial recess to match one bearing and then a hole through for the other bearing. But for me it's dead easy, I just base it on the 33109, so I'm going to look up what size hole I need for that. So 33109, so we're over here somewhere, 33109, so it's this column here, and the DA value varies between 69 and 73, so I suppose that's, I don't know if that's 70 we'll call it. So let's put a hole in there for that. And we'll do that very simply. We'll just do extruded cut, select this face, draw a circle on it. Just wiggle the mouse over the outer circle to get the centre to come up. Select the centre, draw a circle, put on a dimension, 70. Okay, accept that. Sketch plane, yep, and we'll just do through all. Okay, so that will just go straight out the back of the case like so. We need to put on the other recess for the other bearing now. It'll do the same diameter of this one, but I'll just look it up anyway. So here we have our bearing here, and it's 80 outside diameter. And in my spreadsheet, the important dimension is, this is on the output sheet, is the bearing gap, so it's the distance between the two bearings. Okay, so for me that was 20. So what I'm going to do is do another extruded cut. Tell you what, we'll zoom in a bit down here first. See what we'll do a bit more easily. Extruded cut. Select this back of this bearing boss. Okay. Draw on a circle to match the diameter of the bearing that we're going to draw. Now you could just snap onto there, but I prefer to actually dimension it, just in case it's not the same. Okay, so that was going to be 80. Okay, so let's finish the sketch. Now, what you do is you do from offset, and you offset by the 20. Now, it's offset it in the wrong direction, so you just flip that. Now it's over there, and then you do through all again. And, hey presto, you've got in there the recess for the other bearing. Now, I can adjust the length of this boss and have no effect on this position of this feature at all. The important distance is from this face to this face, so that's what's best if you dimension it in that way. Right then. There's quite a few sort of fiddly bits today, so okay, let's go back to the assembly, I think, and so we'll close that, say yes, yes, and I guess we might as well put in our bearing. So, toolbox, I hope I can remember how to do this. SKF, bearings, taper roller bearings. Okay. So you put that back to front. Just make sure we get the right bearing there, 3109, so we'll select that. As I say, put it in back to front, but that's okay, we can add on relationships for that. So, assembly, mate, it's this end face here, onto this face here, and over define the assembly. Put in a relationship there by mistake when I placed it, so we just have to delete that. I did wonder what was going on there. Has it got a concentric? It has got a concentric, delete that as well. They try and make these things smart so that it's supposed to save you time, it usually wastes more time. Right, so now we put in making relationships, so we'll select this end face, this face here. It's done it back to front, so we need to do flip there for the alignment, so that's got that one done. And then we'll make the outside diameter to this bore here. It's got that done. Right, I think that's okay. Turn the section on and off. Okay, so that's got that on there, and if your shaft has been dimensioned properly, when you do that, you should end up that this undercut here is just underneath the bearing. Okay, if I just true that up a moment, zoom back in. Okay, so the undercut is just inside the bearing. And then this diameter here should be the same diameter of the bearing. It's actually going to be for a lock nut and lock washer that go on here. Now, every year somebody will put on a lock nut and lock washer that is a smaller diameter than the bearing. They are very specifically designed to be exactly the same size as the bearing. So don't choose any size other than the internal diameter of the bearing. Alright, the top of the teeth on the thread is slightly smaller, but you're talking of tiny fractions of a millimetre. But there's no question it's going to get rubbed by the bearing when you assemble it. It will just slide on there nicely. So, right then, so we need to do this lock nut and lock washer. Unfortunately, they're not in a catalogue, so we can't just bring them up, so we'll have to create them ourselves. So we'll save our assembly for a moment. Save all. And we'll do a new part. New. Okay. Right then, let's see, let's do a sketch. Front plane. This is going to be a revolved part again, so we'll just do a centre line to start with. Oops, that wasn't horizontal for some reason. So we'll escape from that and undo. We'll put in a new line. And then we'll draw on, this is the shape I want here. Draw this fairly coarsely so that I'm making sure that this is perpendicular to the other line, and then this will also be perpendicular to that line or parallel to the other one, and then we'll go down to here, so, and then across to there, right. Now, I'm going to add on a relationship here, add relationship, I'm going to make that line and that line equal in length. Okay. What I'm actually trying to create here is this tap washer, and essentially I've got this dished shape here, so what I'm going to be doing is dimensioning it to match that. So what we need to do is D1 is the diameter to that inner corner. So for me, my bearing was 45 diameter. So I take whatever D1 value corresponds, which is 56. Okay, so I'm going to put on here, there, up to that corner. Now I'm always saying don't dimension corners, but in this instance you can. 56. Okay, what else do we need? We need to have dimensions of this outer corner here, and that is going to be, where is it, D2, and for 45 D2 is 69. So here onto here. 69. Let's have a look, what else? We've got an angle in here, I think. That angle is 65 from the horizontal or 25 from the vertical, so put that on. So here onto here, 25. And I think really the only thing missing there is the thickness. So the thickness is T. And for my one, T is 1.25. There you go, and all of a sudden it Okay, so that's got that done. Right then, I suppose we ought to do a revolved feature from that. It's worked out which line is which, so that's good. So it's got the basic dish. Doesn't look much like a tap washer yet. Okay, so how do we do that? Let's have a look. We'll do a sketch on the sketch. And we'll do it on a right plane like so. We'll make perpendicular to it. So. And what I'm going to do is I'm going to start off with a centre line from the centre here, and I'll just draw that up vertically. Now, if we go to this handout here, we've got to put in some tabs into this thing, and all we actually know is that the tabs are this width, B wide. Okay, so that's little b, and for me that is 6. So the width of the tab and the gap is about the same at the outside diameter, I would say. So if that's 6, so 6 and then the gap is also, say, another 6, that's 12. And we know the circumference, because the circumference will be d2 times pi. So d2 is 69. And so the calculator on my phone here. So where we calculated on the phone yesterday, right? 69. So 69 times 3.14159 equals, divided by 12 equals, that's saying I need 18 of these tabs, okay? However, you'll notice in the diagram that it's an odd number. So what I recommend is that you either go 17 or 19, okay? So it's normal to have an odd number. I think I'll go 17 because maybe that's not quite as wide as that. So 17, right. That's fine. Now, next thing is I've got to divide 360 degrees by 17. So 360 divided by 17 equals 21.17. I should probably write this down somewhere because I know my phone will cut out on me. It always does. So 21.17. Okay, right then. Let's see. If we go to SolidWorks now, what I can do is draw another line set over at that angle. So and we'll just put in an angle between the two lines. Okay, now I'm going to draw in a line parallel to this from here down to here. And then you go back up parallel to this one. Now it's going to want me to specify that it's parallel. So add a relationship here, add relationship. half the tab width. Okay, oh no, so you put in a whole tab width if you do it that way. So that was 6. And do the same thing on here, from here to here. That's also 6. We'll draw on a circle here, so on the centre, and we'll just come out to that diameter there. And I suppose I could draw another circle actually up here, like so. And I'm going to do some trimming now. So it looks a bit odd what I'm doing, but when I've trimmed it, it won't be. Trim, so power trim, and we can cut off that bit of those 2 lines. We can cut off that, and that for that matter. That, and that. Okay, so we've ended up with a little segment there. Might have to add in a relationship just here. So add relationship, that arc and this arc, and tangential, I suppose, and centric. Need to be tangential as well. So that one. This one out here is going to need some sort of a radius on it, I think, before it's happy. So it doesn't matter what this is. Okay, so we've got our little sketch done, and now we're going to use that to cut a slot in the dish. So, features, extruded cut, and we want to go in the other direction, and through all basically. Okay, so we've got a little nick put in there like so. And this is where the magic comes really. Oh, I need to do one more thing actually before I can get to the magic part. I need to stick in a centre line because I've embedded the centre line in the dish. I need to stick in another centre line, so sketch, front plane, right, let's put that like so. And I'm going to draw on a centre line in the middle from here off like so. That's all there is to that. Now I need to do the bit that's of interest. If I select that extruded cut there, it's a good starting place, and then I do circular pattern. Okay, and I have to select, it's already recognised that I've selected the feature. I now need to select this axis. It's going to let me. Like so. And you'll see that it's offering me cuts now based on the number written in this box here. Well, I need 17 because that's the number of tabs I said I was going to have. And when I do that, I've now got a tab washer essentially. Okay? So, what else have we got to do? Well, we've got to put a hole in the middle, and that's also got to have a tab on it, but so we'll do that. I suppose I'll just do it as sketch and extruded cut as one. We'll select this face here, and we'll draw a circle, like so. I suppose it would be easier if I was looking straight onto this, wouldn't it? So let's have a look on my diagram here. I've got the tab lined up with one of the slots, so that's going to be F, which is not always the same as the tab on the outside, but for me it is, so it's 6, and it's 42.5 from the other edge, so let's have a look. So we need to just draw that in. So we'll put in the dimension for this is 45. And we need to draw on a little slip-on tab washer. I'll say I already have a tab washer that I have created, but I'll save that over the top of it. So there you go. So that's got the tab washer done. Right, next job will be putting the slot in the shaft for the tab washer. Just in case we're all starting to fidget very slightly, and it's quite a long session, 2 hours, so I'll probably stop about past. Okay? But there is quite a lot we have to get done, so we've got another half hour anyway. Right, so we've got that done. So we can close that. And we can create a lock nut in very much the same way. Right, let's take the shaft. So here's my shaft. Where are we? Shaft. Output shaft. And there's the shaft itself, so we'll open that up. And what we need to do is to put on a slot. So this was the diameter where the bearing was. This is where the thread is going to be, and we're going to put a slot into the shaft for that. So, I think possibly the best way of doing this is to create a parallel plane. Let's have a look. I haven't done this for a while, so reference geometry plane. And I'll just select the top plane there. And we'll relate to this surface here. And we can either do it, we can either do it that way, perpendicular, or we can do it parallel. So that will put the plane on top of that surface, you see. Okay? So that's got something for us to draw our slot onto. The advantage of doing this is because it's tangential to this diameter, if we change the diameter, this plane will move up and down with it. Okay, so that's why we do that. Right, let's create a slot in the shaft. So we'll do extruded cut. It's looking for a plane for us to work on, and we know the plane because we've just created it. So I think it might have already chosen that, so we'll, here you go. Now then. We can, there's a couple of ways we can do this, but I suppose we might as well use this as an option. Straight slot. And we choose that. It's lining up the axis there, and we put on a centre line there. And you can just open this up to produce a slot in here. Now, we'll have to position this thing. We really want that corner to be at least up here, so we'll just drag that along, like so, and we can dimension it off one of these features. So we'll dimension it from this edge, I think, position that, and I don't know, we'll make it 22, which maybe is the same as the other edge, it's slightly further in. So 22, we want a width on this slot. So here onto here, and that has to match the tab, which if you remember is 6. Okay, and it's looking for a length of this thing. Actually, we don't really care, but because it's looking for a dimension, we'll just put a dimension on here like so. And as long as it goes out beyond the end of the thread, that's cut into the shaft by the depth of the tab, which was 2.5. If you remember, the diameter of the hole was 45, and we had a dimension of 42.5 to take away from that, so it's 2.5. Yours may be different, it just depends on your particular tab washer. Okay, so we've got that. And that's got a tab washer slot cut in there. Now, it's important that it doesn't cut into that. If it doesn't, you're going to have to look at the diameters. If it does, rather, you're going to have to look at the diameters. What you can't do, and some people do, is that they create this slot and it goes down below this diameter. Well, you can't have that, because otherwise, how would you ever get the tab into the slot? You have to slide it along over that diameter first. So it must be above this level here, must be above the diameter there. Okay. We could also put in our keyway slot, I suppose. So I suppose while we're here, we might as well. Features have to be added on. So again, we'll do insert. We'll do, where are we? Reference geometry, plane. And we'll do top plane here. We'll take this diameter here, and we'll do parallel again, and that puts that on top there. So you tend to machine them both in the same position, but it does start on another level. So we'll now do our slot keyway cut, and we'll look plane onto that. Zoom in here, and we'll just draw on another one of these posers here, and we'll just get it lined up on the axis again, and draw along like so, and then open that up, and then we'll get some dimensions. So for our keyway, we had, let's see if I'm going back to the spreadsheet. Shafts and keys. So this is the output shaft. So my key was 10 millimeters width, and the length of it was 25 long. So it's this box here, 25 for the length, and that box there for the width. So 25 by 10. So there's the 10. And we're dimensioning from here onto here. Now by default it will go for the centres, but we just put that down there for a moment, and we just accept whatever it's given us, and then we'll go to the leaders, and for the two ends we put maximum, and that will actually go out to the very ends there, which is what we want. And now we can come back and edit that dimension, so go back to the value, and we'll make that 25. Okay, so what do we want to do? We want to position this a little bit from the end there, so we'll put on a dimension from, well, we'll go from here up to here, and this time I'm going to put it on, oh wait a moment, sorry, dimension there, from here onto here, and again it's put on the dimension to there. So we just accept whatever it's given us, go to the leaders, and this time we put on minimum rather than maximum. And then we can edit this value here. Let's have a look, what do we want? We want it showing that as it is. 10 there, see what happens. That's way too much. I don't know, 8, something like that. You need a sensible amount of material either side of this, maybe even go a little bit less. there. I've probably made the end of this this hub longer than it needs to be, so I could perhaps shorten that. Okay, so let's get that done. And then how far into shaft does it go? Well, if I go back to spreadsheet, it says here key depth in shaft 5 for my one. So we cut into the shaft by 5, so the guy keeps looking in through the door here. I don't know what he wants. I think I should go and speak with him. He's annoying me.
With the chair. Hit him with the chair.
He thinks there's a lecture here at 4. Right then, so that's got that done. So we'll just close that. Save changes. Yes. Okay, so we've got our slot there. Now, the fact we've got that slot there means that we can actually put on our tab washer. It's always useful in the assembly if the tab washer and so forth is lined up vertically. So to make sure it is, I think I might add on a relationship onto this shaft, if it will let me. Right, so mate. And that's what I want, top plane. And I'm going to take the bottom of that tab washer slot, and I'm just going to say I'm going to make it parallel. Now that will ensure that that shaft always remains vertical. It sort of locks it, which in some circumstances you might not want it locked, but for me it works because it means the tab washer will always line up with the section. So we'll get our tab washer and insert that into the model. So browse. I created a folder to put my tab washer and lock nut in, so washer tab, just plonk it down there. Again, I'm going to have to turn on and off the section. And you want the sort of prongs of the tab going outwards from the bearing. So you take the back of it. So what we'll do, like that, we'll put a relationship on this back face here, up against this face on the bearing. Okay. We'll line up. I really have to zoom in here for this. We'll take this face here. Okay. And I'll just have to zoom out and zoom back in again. And this face here, to line that up. And then the final one will be this diameter here and this diameter here. And that should now have that tab nicely fitted into place there. So we can turn on and off our section again. And you see that that tab washer is now, oops, let's just zoom out a little bit. The tab washer is up against the bearing with the tabs pointing outwards. Okay? So that's got the tab washer in, and we'll also put in that lock nut. So let's do insert, and the lock nut, you've got to create, so nut bearing. So these are made for the sole purpose of locking bearings, so unfortunately that does mean you can't get them in standard catalog. Now they have a big chamfer on one side. You see on that side it's got a big chamfer. The big chamfer side goes up against the lock nut, up against the tab washer rather. So we will put mate this face here against the tab washer. Okay. I'll put, let's have a look, we'll take this edge here. This is getting hard to see now. That edge of the tab there, so it's got that lined up like so. And then finally we'll take that diameter there against, it should really be this diameter, but I may put a thread on that, so I'll go for that diameter instead. Okay? So that's got that done, and we can turn the section on and off. Now I wanted to get that lot done because it means then that I can determine where the end of this thing is, because basically what we have to do now is we have to put some sort of lip seal on here in the same way as we had on the input shaft, but because of the big diameter of this bearing we can't just push in a lip seal, because you can imagine the lip seal would have to be enormous. So we're going to put a housing that fits onto the end of this. So I want my housing to bolt onto here, and we need to get good access to this tab washer, so you don't want to be burying the face of this housing too far from where this tab washer slot is, because you need to get something in there to be able to lever those tabs into position. So where does that put us? I'll tell you what, we'll measure from, what will we? Let's try editing this thing dynamically just for a change. Right. Okay, so face output. We'll do edit dynamically, and we want basically that boss there. We're going to edit. And what I'm really going to do is reduce its length until it's sort of reasonably close to the tab. Something like that, I think. Okay? So I'm just trying to imagine being able to get that tab washer. You don't want it too far back, because else you have to actually create a great big housing to sort of bring your seal out here. So make it so it's sort of part way along the nut. There you go, that'll do. So you can see where that is. Yeah, so I'm happy enough with the position of that. So we'll do that. That's okay. So I think you can imagine getting something into there and getting access. Also, I'm going to put a seal housing onto here, and it needs to spigot onto this. So to do that, I need a recess in here so that the spigot can go in there. That needs to be a little bit bigger than the bearing. So we'll do that. So let's open up the base directly, and we'll put on a recess on the end there. So cut out. face here, draw a circle on the centre. Oh, that's not very good, is it? Can't be too slick. That's better. Put on a diameter here. It just needs to be 1 or 2 millimetres bigger than the diameter of the bearing itself. So my bearing was 80, so even 82 would be perfectly adequate. It's just so that it's not the same diameter, basically. And we're going to put a spigot into this. You're going to have a chamfer on the end of this, which is probably going to be a 1x1 chamfer. You'll have a chamfer on the end of the spigot, so that's a 1x1. So that means you've lost 2 millimetres straight away. So to get a decent engagement, you'd need at least a couple of millimetres. So the spigot itself, including chamfer, would be about 4 to 5 millimetres long. So if I cut that in, say 6, that makes sure that there's a little bit of clearance in there. So that's just my logic going on there. And I've said I'll put a chamfer on it. I'm going to stick chamfers in all over the place, I think. We've got all these bearing bosses done now, so we'll put on chamfers. And we'll put on one on there. You can do this almost at any point. I'm just choosing to do it now. There you go. You do need to put them in at some point. So that's got that on there like so. Okay, we're coming on quite well here. What else can we do? Well, I suppose the height of this is defined now. The height of that's defined, the height of that. We could add on some draft onto these, so I suppose I'll do that. Until you've actually set the position of these things, best not to put on draft. Document's not been saved for at least 20 minutes, so I'll save it just to keep it happy. Okay, so the draft you have to put on, unfortunately, each boss, because each boss is a different height, you have to specify the draft for each boss individually. So, 1, draft on this one. Right, what else are we going to put on here? I'm going to put on a seal housing onto here, so I'll need something to screw it into place. So I'll need some bosses put on here. They can start from the end of this. So let's have a look. We'll do extruded feature, select this interface here, we'll do that, zoom in here, and I'm just going to draw on a circle about here for the moment. And let's have a look. The diameter of this circle needs to be about 18 diameter. This is because I intend to use 8mm screws with it. And we need to position this so it's reasonably close in here. So we'll put in a horizontal dimension here onto here. And I don't know, I'll make that 27 or something for the moment. And we'll put in a vertical dimension from here unfortunately it doesn't update the other one until it needs to go out a little bit more. Try 38. That looks okay. You must make sure that that doesn't encroach into there, because else you'll have a little bump inside this area here, which of course you can't have in reality. If you're forced into that position, then you're going to have to sort of cut something off this boss. So we'll do that. So it's got that. Finish the sketch there. Now then, let's just rotate this a bit so we can see what's going on. So we're going in the wrong direction. We need to do up to body, and we'll select this as our body. Okay, and I think we'll add some draft on here. So draft 3 degrees, and it needs to go outwards, not inwards. That's got that done like that. And when you've done that, just have a look round to make sure that it's not going to actually stick through anywhere. Now, if you did up to body, it shouldn't. Even if the hole on the other side actually were bigger than that diameter, it shouldn't actually allow that to encroach through. So that's got that boss there. And what we'll do is we'll use our pattern again to create the other bosses. So we'll do circular pattern, and it already knows I want to use that boss. Now, previously I did an axis. You should be able to do it off a diameter. So let's try taking that diameter there, and it's happy enough for that. It's trying to put in 17 bosses at the moment because that's what I had before. So we need to drop that down to 4 basically. Go. So that gives me something to screw on my my seal housing onto. Okay. Right. What else do we want to do? I want to add on a couple of bosses on here and here. This is for adjuster screws. Okay. Now, the adjuster screws are going to be set screws. So if we look up in here, here are hexagon socket set screws, and there's a table that gives their lengths and so forth on them. I've already got one that I've created. So I have a set screw here that is M12 by 20. So you want to go for something like an M12. Okay? And you want the boss to be about 20 millimetres as measured from the inside of the recess where the bearings are. So let's go to the solid model here. So what I'm going to do is I'm going to put on a boss, extruded boss, select the bottom of that hole there. Okay, draw in a circle, so make sure it's concentric to that. Draw in a circle. Now if my screw's going to be 12 diameter, I want to say double that plus 2, so let's make that 26. Okay, and what I shall do, because I want it 26 at the end where at the smallest end of the thing, I'm going to do offset plane, and I'm going to offset by the amount that I want the boss to be long. So I'm going to make it 20 long. It's extruding in the wrong direction at the moment, I know. So we move it out to there. So you see it's now sticking out the back there. We'll do, I don't know, up to body. So there's the body there. And we'll add on some draft. So outwards, that's got that like so. Okay. And then we'll do another one on this other one down here. So extruded boss. Select surface, do a circle. Six. Right. Then we want to do offset 20. Change the direction. Up to body. Draft outwards. That's got that on there. Okay, so let's do save. And close. And we're starting to sort of make a bit of progress now. So we can tap these holes and put in screws so that you can adjust these adjusters. What I'll do next week is I'll put on a seal housing on here to carry a seal on here, and then do a few more of these fine details. I am going to have to go through quite a lot in the next few weeks because we are actually starting to run out of time. The other thing is I do have some videos of some of this stuff, but not quite the way I've been doing it this year, but close enough. And I'll try and get those up and available for you soon to help you read them. I didn't want to put them up too early because otherwise you just don't come to the lectures, you know. And if I change the method slightly, then you're going to be in a mess. So you don't need the videos, but if you get stuck, they can be useful. So that will go up in the next week or two. So okay, so let's save that.